Good morning. I, thank you. It's amazing that so many of you guys came to listen to our talk. We were not sure how to position, how to design this talk. So, and we definitely didn't want to sell product, right? We didn't want to tell you, oh, buy our product and whatnot. So we decided to give you a entry point on how to think about Android security or app security in general. So our presentation today is going to be on how to protect code, keys, and data from a more conceptual perspective. Before we dive in, I want to basically highlight how to think about security in general, right? If you, just by show of hand, can you give me a signal, how many of you guys are already applying security concepts to your development process? How many of you guys think about, oh wow, okay, shoot. So this might be a little bit too entry level for you, but I always encourage you to come to our booth to dive into a product demo and challenge us on how to do things properly. But coming back to our starting point on how to think about conceptually, I want to start with just trying to think about different life cycles of your application that are challenged with different attack vectors, right, or threat types. The first stage of your application is obviously the development process, right? So during pre-release, when you change things around in your code, right? When you introduce a library on SDK, this might be a attack vector that can be used to introduce vulnerabilities to your code, right? If you use a library, how many of you guys do use SCAs to scan libraries or SDKs before you implement them into your code? All right. Okay, so you are on the right presentation. You're on the right talk track. This is something that we see quite often because oftentimes, obviously, developers, they are not, your focus is not to check everything in terms of security, right? You want to build applications. You have a very clear focus on what you want to achieve, and security might not necessarily be on a very high position in this priority list. The second step or the second stage in the application lifecycle that you should consider from a security perspective is after you publish the application, right? Ideally, you want to reach as many people as possible. You want a large user base, but then if you publish your application, threat actors also gain access to your application. And they might take your application from the Google Play Store or the App Store and try to reverse engineer it. They will try to understand the logical workflow of the application to see where they can tamper with it, right? How can they abuse your app for their gains to, I don't know, steal PIIs of your end users or attack the backend or try to repackage the application to fool other unsuspecting users. And then the third stage would be during runtime, right? If you install your application and then it gets executed on a rooted device, on an emulator, it might also be prone to attacks or to other vulnerabilities. So if you keep this mind map in mind, right, and this is how I want to guide you through it, right? How to think about security in terms of mobile apps. To give you some examples, right? I did some research because I didn't want to just keep it theoretical. So I did some research and tried to find some tangible examples of apps that have been fallen victim to certain incidents. And the first one that I want to get your attention to is a buy now, pay later application. I was told I can't use app names here, so this is why it's so cryptical here. A few years ago, there was an incident with a buy now, pay later app where a dev did a config change, right? And that config change had an unintended further effect that led to, or that changed how data was cached between the app and the backend, which then led to something very critical that the other end users of that app were able to see other users' private data, right? And they could see I don't know, what they would buy, they could buy other things, right? So you can imagine how critical these effects are. And this was just human error, right? Someone made a mistake. Probably that someone didn't use dynamic testing, right, to validate their code before they would publish it. Another example was a malicious library that we saw in the APAC region where threat actors have been tampering with an SDK, right? And that SDK was then used in other lifestyle applications. And it affected actually over 100 million devices, right? So you can imagine the effect that this has. And obviously the developers never had any bad intentions, right? This is something that can happen by accident during your development process. And then to give you an example for incidents that might happen after your launch application, there was a telco provider a few years ago that had a problem with leaking APIs, and threat actors only learned about, discovered that problem because they reverse engineered that, right? So they took the application from the App Store, they tried to understand the logical workflow, and they understood, hey, wait a second, actually the way how this app was querying the backend server, they would send a user ID, right? What happens if I change the user ID and challenge that API with it? And then they learned I can change the user ID to retrieve information of users that are not me, right? So I could retrieve information on I don't know, I could steal a lot of PIIs basically, which then led to class action lawsuits in the US, right? A lot of damages caused. Another example was the crypto wallet a few years ago, where developers accidentally, probably, hard-coded private keys. Probably not the best practice, right? Don't do that. But then the threat actors learned about it by just monitoring the traffic flow of the application, right? Just monitoring the traffic flow, they saw that actually the app was syncing private keys in plain text to a monitoring service, probably just for debugging, right? Just a development mistake, very common error, but threat actors learned about it by monitoring the app after it got released. So think about, ideally think about how would you handle these situations, right? How would you prevent these things? Moving on, to give you an example for on-device or on end-user devices, there was an application for ride-hailing. I'm pretty sure when you arrived in Berlin, right, you took a taxi or some car from the airport. One of these application vendors had an issue with a IT contractor, right? The threat actor was retrieved the credentials of that contractor through a malware. And then there was still MFA in its way, right? So the way how they dealt with that was just by bombarding that end user with authorization requests saying, hey, we had some change in our security, right? Please log in to verify that it's really you. And they would spam these authorization requests to the point where that contractor would eventually say, yeah, okay, whatever, authorize it. And that's how threat actors gained access to the corporate VPN. And then from there, they were able to laterally move forward and steal a lot of data and compromise the integrity of customer data of that company. And my last example was a social media app a few years ago where actually a vulnerability in the operating system led to threat actors being able to take over accounts of social media influencers, right? Also, here there's a lot of money in this these days, so catastrophic consequences. So all these are examples that are really tangible. These happened in the past, right? And you can see how if those developers would have thought about security from these perspectives, right? Not just, I don't know, security is something that someone else is going to deal with. I'm not going to be held liable for that, right? But thinking about security in terms of, hey, how can I make sure that the application that leaves my desk, so to speak, is safe, is clean. There's no vulnerability that I introduced accidentally. How can I make sure that the application is very difficult to tamper with, right? If anyone tries to understand my logical workflow, how can I prevent them from it? And then once the application is how it's supposed to be, right, and it's run on the end user's device, how can I make sure that that I prevent the execution of the application in untrusted environments, right? Like on a rooted device in these examples. So I'm sure if you follow these examples, you probably think, odd that this happened, right? This would never happen to me. So I want to do a little thought exercise here. How many of you guys have measures in place to harden your code? All right. Are you just shy, or is it really no one is thinking about that? That's actually a very fair representation. So at Imperium, we do our own research, and I encourage you to go online and check out our Global Mobile Threat Report. In our most recent Global Mobile Threat Report, we actually also came to similar results. From our queries, almost 4 out of 5 developers confirm that they are not really applying measures to harden their code, right? If we analyze the applications, we can see they are very fairly easy to reverse engineer to understand their workflow. How many of you guys apply on-device protection to your applications? Like how many of you guys apply root detection, for example? Very good, very good. Still, in our survey, it showed that almost 3 out of 4 apps come with very insufficient root detection or insufficient on-device protection, right? Of those of you who raised your hands for root detection, how many of you guys do malware detection? Okay, that's a few less. Then how many of you do have measures in place to protect data, right, or to encrypt data? Very good, very good. And this is also what our survey shows. Similarly to proper encryption measures, right? And my guess is it's because the operating system vendors provide us, or the IDE vendors provide us with a lot of tools to actually take care of these things. But then, as we saw in our previous examples, right, security is not just one thing. You can't just apply encryption and then be safe, right? Threat actors find attack vectors that are easiest to go, right? They're not going to try to break your encryption because encryption just works very well, right? So they're going to try to find other ways to tamper with the application or breach your security. Especially the part about on-device protection is very, very important. I brought a different example here. You all probably know about WhatsApp, right? Everybody knows that WhatsApp does end-to-end encryption, which sounds very safe, right? So data in transit is secured. But then what about data at rest, right? If you rely on the data in transit security, threat actors still might be able to gain root access to that device, right? And once they have root access, they might have access to encryption keys, and once they have access to encryption keys, they might decrypt databases in which messages, in this case WhatsApp messages, might be stored. As you can see here in this example, the messages that you see in the app are retrievable from the database once I gain root access to that device. So with all these examples now out on the table, right, the challenge that developers face, from our perspective at least, is you have to kind of make a trade-off, right? You have to decide between security and velocity of your app. You have very tight development life cycles, right? You have a huge list of backlog, you have crazy demands from your customers, and you have deadlines until yesterday, right? So you have that pressure, but on the same side, you have a certain security demand, right? If something happens, you're probably the first person that people will point their fingers at. So the trade-off is either do you release vulnerable apps, right, or do you delay the release cycles of your applications, which is a painful place to be in. So to give you some pointers on what you can do about these situations, to go back to our mind map here, in pre-release you can use things like security testing tools, right, or software component analysis to vet your libraries. This is something very, very important. I would encourage every one of you to do that. I had a very interesting conversation yesterday with a colleague from Qualcomm who was educating me on the latest advancements in AI, right, especially for development. And we touched on a topic where the question then became, why are so few of developers using AI to write code? Just by show of hands, who here is using AI to write code? Okay. It's not super representative in our conversation, but still. And then we were discussing back and forth why that might be, and we touched on the point that there is a concern of security, right? There's a concern of what happens with my intellectual property once I upload source code to an AI. And I guess you can apply the same principle to libraries and SDKs that you just introduced to your application, right? So make sure to vet everything that goes into your code. After you develop the application, once you distribute the application, you publish it, to in order to prevent or to make it as difficult as possible for threat actors to tamper with the application or to reverse engineer your applications, we recommend to apply tools like app hardening, obfuscation, to do exactly that, right? To make it as difficult as possible for a third party to understand what you're trying to do there. And then on end-user devices, make sure to have some form of anti-fraud, ideally some runtime self-protection capability within your application. When you do your research, right, you probably come across, you will come across different tools that are free of use, right? You will come across certain commercially usable tools. I don't want to touch on the commercial use applications, right? I don't want to place any ads here. So let's talk about the freely available tools. In the pre-release phase, you will come across a tool called MobiSF. I'm sure most of you have heard of it, but be aware of the blind spots of these freeware tools, right? MobiSF, tools like MobiSF, they can be fully integrated into your CI/CD, right? Automation is very key in that step. They do a good job on analysis of code, but then they rely on very common security very common threat patterns. So they might not do a very good job when it comes to identifying runtime issues, right? That would require further penetration testing or more deeper analysis of threat vectors. In terms of your code hardening, R8 might be a very common tool, right? I'm pretty sure all of you have used it within your IDs. But still, be aware that R8 is not doing a very good job of delivering runtime protection, right? It's hardening your code to some extent, but it's not really fix for everything, right? It's going to slow down your attacker to understand your code, but then it's still fairly easy to deduct what you were trying to hide here, and also it's not providing a lot of protection once your app is deployed and installed in, I don't know, an emulator on a rooted device. And the same goes for root beer, right? Root beer, again, does multiple checks for root detection, which is very solid, but then it only checks, I think, at the very beginning, once the app has been launched, right? If you have situations where an attacker might gain root access after the app has been launched, then you won't pick up on that. Also, with those freeware tools, you have to be aware that they are also accessible for threat actors, right? They will understand what you're doing, how you're doing things, and they will find ways, or they will at least try to find ways to get around these measures. So I have to keep an eye on the time here. Our recommendation, therefore, would be that during development, make sure that the tool that you take into your consideration scans your binaries, right? You want to have dynamic scans. You don't want to just look at your source code. You also want to see how your binary behaves, right? You want to understand how what issues might be occurring during when your application has been deployed, how your application behaves in different use cases with different user behavior. Ideally, the tool that you apply should give you some recommendations on how to optimize your workflows. You also want to keep an eye on compliance, right? I'm pretty sure that not too many of you might come with a law degree or something, right? And compliance is constantly changing. So in order to keep up with compliance, you ideally want a security testing tool that also references compliance issues here. Then when you move on in our mind map, right, in our life cycle of the application, when you distribute your application, make sure that you have a measure in place, right, a tool, a library, that helps you with securing data in rest and in transit, right? Make sure that you have a rough idea of how you handle keys, right? Try to be as independent as possible. This is something that we also seen in different geos. Not every user is running on the latest iteration of an iPhone or the Pixel device, right? You might have a very, very significant user base that comes with very limited hardware. So keep that in mind when you rely on built-in encryption models, which are definitely good, right? But they might not be available to a big majority of your user base that you try to reach. And then also try to make it as difficult as possible for threat actors to reverse engineer application, right? So harden your app code, try to challenge the vendor that you're selecting, right? The tool should provide not just a few things, they should provide everything in terms of anti-reversing, anti-tampering, anti-debugging. Also, you don't want to just make it as difficult for the threat actor to tamper with the application. Ideally, you want to gain visibility into the tampering attempt, right? Because threat actors will constantly try to find new loopholes. If you don't have any visibility in what threat actors are trying to do on how to penetrate the application, you don't, you lose touch with yeah, you fall behind the curve, as I say, right? So a threat actor might actually be successful with penetrating the application. You will never know if you don't have that visibility, right? And then during runtime, when the application is on your end user's devices, make sure that your application is capable of detecting and responding to threats, right? You just don't just want to have root detection in place and then it crashes the application. Maybe you want to have a more granular approach to threat mitigations, right? Maybe you want to weave that into the logical workflows of your application, like logging out the user from, I don't know, from the app, or just limiting certain features within the application if certain security breach has been detected, right? So let's say, I don't know, the user's running on an outdated OS and there's a CV that is known to that operating system version. Maybe you don't want to crash the app all the time, right? It tampers or it messes with the user experience. In those cases, it might be feasible to just educate the user. Hey, an update is important for this and that reason, right? So challenge the vendor basically to provide some granularity in threat mitigation. Also, make sure that the vendor is allowing you to act to certain changes in the threat landscape, ideally in real time. You don't want to always have to start a new development cycle or release cycle for every threat change that we see out there, right? So yeah, these would be our most important tips. And then lastly, the tip that I want to give you is try to find some synergy between those tools. Ideally, find a vendor that provides a platform that helps you to integrate all these tools, right? You don't want to have any operational friction between different security tools. If you have a runtime protection that protects the app from, I don't know, running on an emulator, and then you have a security testing tool that does exactly that, you don't want to have any friction between those things. It creates a lot of admin costs for you. It creates a lot of, it slows down your release cycles. It makes total cost of ownership really, really difficult. And then also leverage other security resources that you have in your organizations, right? Your customers, your clients, there's a good chance they already have playbooks in place, right? There's a good chance they have a certain SOAR platform that you can integrate with. If you choose the right vendor, they integrate to ticketing systems, to CMs, to threat analysis tools that also help you to model the threat types that you will be facing out in the wild. And with that, I believe I am already over time. So thank you for your attention, thank you for your consideration, and I invite you to come to our booth to get a live demo, get a free license maybe, and see you around.